Good morning all of you. In the last class we have completed the disinfection process of water, and today we will discuss about the next topic, that is water softening. So what is softening of water? The reduction or removal of hardness from water is known as softening. And it is not always essential to soften the raw public supply to make the water safe for public use, because the normally prevalent hardness in raw water are not too high, which will cause any major harm to human health. But softening, the advantage of softening lies mainly in the reduction of soap consumption, lowering the cost of maintaining plumbing fixture, and to improve the taste of food preparation. But for industrial supplies, the softening is more important because the hard water are likely to cause scaling troubles in boilers. Then next, what are different types of hardness? So there are mainly two types of hardness. One is temporary hardness, which is caused by carbonates and bicarbonates of calcium and magnesium. And second one is permanent hardness or non-carbonate hardness, which is caused by sulfates, chlorides and nitrates of calcium and magnesium. However, the permissible hardness for public supplies normally ranges between 75 to 115 milligram per liter. Next, we will discuss about the different methods of removing hardness. So first we will discuss about the methods which will remove the temporary hardness. So there are two methods. One is boiling and second one is addition of lime. And for removal of permanent hardness, there are two methods. One is lime soda process and second one is base exchange process, which is generally called zeolite process. So first we will discuss about the methods to remove temporary hardness. So boiling. So this boiling, the calcium carbonate is generally exist in water as calcium bicarbonate because it is easily dissolved in natural water containing carbon dioxide. So when such type of water is boiled, the carbon dioxide gas will go out and it will form the precipitation of CaCO3, which is insoluble and can be sedimented out in settling tank. So see the chemical reaction. So this is the calcium bicarbonate. When heat is applied, it will form calcium carbonate, which is insoluble in water, and it will settle down in the settling tank. And carbon dioxide is formed, which is go out. But the magnesium bicarbonate, so this method is suitable for calcium bicarbonate, but the magnesium bicarbonate and magnesium carbonate cannot be satisfactorily removed under this type of reaction, because by this reaction the MgCO3 will obtain, which is soluble in water. Therefore, for magnesium bicarbonate we cannot use the method of boiling. And also the boiling process is not adopted for public water supplies because it is not possible to boil a large amount of public water supply, and hence boiling is not adopted for softening. So second one is addition of lime. This is the second method. So here you can see the following reaction. So the lime is generally added in the form of hydrated lime, that is CaOH whole 2. So when this is the magnesium carbonate, when react with hydrated lime, it will form magnesium hydroxide, which is insoluble and settle down, and it will form CaCO3, that is calcium carbonate, which is again insoluble. Similarly, when magnesium bicarbonate is present, it will reacting with hydrated lime, it will form calcium bicarbonate and magnesium hydroxide. Then this calcium bicarbonate will again react with lime to form calcium carbonate, which is insoluble. So this calcium carbonate and magnesium hydroxide, which are formed due to these reactions, are insoluble and can be easily removed in the sedimentation tank. So this method is suitable for softening water which contain only temporary hardness, that means carbonates and bicarbonates of calcium and magnesium. But this method is not suitable for water containing temporary as well as permanent hardness. So for permanent hardness, we have to adopt some special methods. So let us discuss about the method of removal of permanent hardness. So the first method is lime soda process. So in this process, lime and soda ash in the form of Na2CO3 are added to the hard water. Lime and soda ash are added to the raw water. Then it will react with the calcium and magnesium salts so as to form calcium carbonate and magnesium hydroxide. So these precipitates can be removed, can be sedimented out in a sedimentation tank, and these can be removed. So the chemical reactions are as follows. So first, this is the which type of hardness? This is the carbonate hardness of calcium, that is calcium bicarbonate. So when it will react with lime, so previously we have already discussed in the addition of lime, so it will form calcium carbonate, which is insoluble. Similarly, this one is the carbonate hardness of magnesium. When this will react with lime, it will form carbonate hardness of calcium, that is CaHCO3 whole 2, which is calcium bicarbonate. So and MgOH whole 2, this is the magnesium hydroxide, which is insoluble. And this one is the magnesium carbonate, which is carbonate hardness of magnesium. When it react with lime, it will form MgOH whole 2, which is insoluble, and CaCO3. This one is also insoluble. Then we will come to the, so these three are carbonate hardness of calcium and magnesium. And so lime can reduce the carbonate hardness, but in permanent hardness there is presence of also the non-carbonate hardness of calcium and magnesium. So these are non-carbonate hardness of calcium or magnesium. See, this one is MgCl2. So this one is the non-carbonate hardness of magnesium. So when this react with lime, it will form MgOH whole 2, which is insoluble, and it will form in addition to that CaCl2, which is again one non-carbonate hardness of calcium. So this non-carbonate hardness of calcium, that means by simply addition of lime we cannot remove the temporary hardness, permanent hardness. This one, the permanent hardness, that is MgCl2. This one is the chloride of magnesium. So this one is permanent hardness. So when it simply add with lime, it will form CaCl2, that is again non-carbonate hardness of calcium. Okay. So in order to remove this non-carbonate hardness of calcium, see here we have to react this with Na2CO3, that is soda ash. So when this will react with soda ash, it will form CaCO3, which is carbonate hardness and insoluble in water. Similarly, another permanent hardness is MgSO4. So when this will react with lime, it will form MgOH2, which is insoluble, and it will form CaSO4, that is again one non-carbonate hardness of calcium. Then we have to react this non-carbonate hardness of calcium with soda ash. So by reacting this, it will form CaCO3, which is insoluble in water. So from this you can easily mark that the lime helps in removing the entire carbonate hardness. See here, lime, this one is these are the carbonate hardness. Okay. So for removal of this carbonate hardness means temporary hardness. So this can be removed easily with the lime. And when this lime react with non-carbonate hardness of magnesium, it will form into non-carbonate hardness of calcium. See here, when this lime react with, these are the non-carbonate hardness. These are the non-carbonate hardness, that means permanent hardness. So when they react with lime, they will form non-carbonate hardness of calcium. And this non-carbonate hardness of calcium is finally removed by soda ash. So this non-carbonate hardness of, these are the non-carbonate hardness of calcium. When they react with soda ash, they will form the CaCO3, which is insoluble. So lime soda helps in removing the free dissolved carbon dioxide also, if it will exist in the given water. So see the reaction. This one is the carbon dioxide. When it reacts with lime, it will form CaCO3. So this carbon dioxide can also be removed. So these sodium salts, these are the sodium salts which are formed and in this method are soluble in water, and these are not generally objectionable. So most of the calcium carbonate and magnesium hydroxide which are formed, the calcium carbonate and magnesium hydroxide which are formed, get precipitated and can be sedimented out in the sedimentation tank. So this is all about your lime soda process. So in the next class we will discuss about the another method of removal of permanent hardness, that is zeolite process. Thank you.